All right. Well, hello, everyone. Welcome to this joint webcast between Semgrep and Lugapel. My name is Jason Kinsfather. I'm a senior solutions engineer here at Semgrep. We're an application security testing platform that provides static analysis, software composition analysis, and secret scanning solutions. And I'm joined here today with Matthias Ferreira from Lugapel, who's the main distributor for Semgrep in the Latin American region. Um, hand it over to Matthias to introduce himself. But thank you so much for joining us today.
Hi, Jason. Thanks for the presentation. Hello, everyone. I'm Matthias. I'm the Regional Security Sales Director for Lugapel. As Jason mentioned, we are the main distributor of Semgrep. From my side, I work closely with engaging potential clients and new customers. But previously, I was the technical manager here in Lugapel. So what you will see throughout our presentation with Jason is our own experience, hands-on experience on the region. So I hope you get some great details and insights of what we can do together.
Thank you so much. So today's webinar, we're going to do in kind of two parts. First, Matthias is going to give kind of an overview of the application security testing market in Latin America, some of the challenges that it's facing. And then I'll kind of talk about the history of static analysis and the tools and the challenges that it's faced, and how Semgrep is currently kind of rewriting the rules by using AI to enhance static analysis. So after that, we'll have some brief moments for question and answer, but if you have anything during either of our presentations, please drop it in the chat and we'll try to address it. But yeah, with that, I'll hand it over to Matthias. Have him go.
Yeah, thank you, Jason. So what we've been seeing here in Latin America is that Latin America is an ever-growing market. Normally, we're actually at the moment we're catching up on the trend of digital economy, and that's been growing a lot. Actually, Latin America's digital economy is growing 2 times faster than the global economy. So what we've been seeing on all the companies here and on our hands-on experience working with companies on the region is that normally companies that weren't using digital business are now evolving to having digital business on their portfolio, but also we're seeing creation and a growth on digital enhanced or digital companies that rely a lot on their applications and on their processes to fulfill their business operation. This rather rampant growth that we are seeing has actually impacted directly on cybersecurity and on the needs of the companies. What we've seen is that this immense growth has developed new applications, new APIs, new processes, new applications that are actually client-faced, but also internally used. And the business operation heavily relies on those flows. So this need to grow and to be on the digital economy has made that the companies have allocated budget and investment to develop these tools or these solutions or these applications that are client face. But what we've seen is that even though that these companies understand their need to be present digitally and have grown their surface a lot, they actually haven't caught the trend with the security. So what we're seeing is that the surface and the perimeter that we have to secure, it's growing rapidly. The security teams are unable to catch up onto it. Mainly, we will talk about the reasons why this is growing, but one of the biggest pain points here is that when we're talking about security teams, they aren't growing as in part to how the development is growing. And we're also seeing a shortage of hands and talent here in the region to add to our security teams. So for security teams and for the company itself, it's been a security risk trying to give proper security to all of this on the meantime. So what are we actually seeing on the market? This is from a survey that was conducted on the for CISOs from different companies, and 92% of them mentioned that the companies experimented a breach in an application developed by them. What this means is that our applications are vulnerable and are being targeted by the attackers. Why? Because we, as I mentioned, we are developing every year even faster, and we need a really strong time to market to actually make profit of what we're doing. So we're seeing an increase of attacks year after year. This is the normal trend, but actually they are targeting at the moment our own application. Why is that? Because it makes it easier to target the applications. Some of the attacks are easily replicable throughout other companies or other organizations. So this is actually a risk. And we then survey when were these attacks happening, and 92% of those who mentioned that were attacked said that the security breach occurred on the last 12 months. So what does that makes us see or understand is that there is a actually really high potential of being attacked, and the attacks are occurring lately, so or on the nowadays or day-to-day basis. So we are actually on a great at the great risk, and this is going to happen to everyone. So what do we want to pursue with all of this? Is try to reduce as much as possible the impact that it might have a successful attack or an intended breach on our applications. What's the risk that we can face? So actually, after that, we asked how much of the business operation was depending on the applications, and 77% of them said that at least half of their business operations is reliant on those applications. So this number actually what says is that it just backs what we were seeing on our experience, that an attack or a successful attack on one of our applications, it's just not only the technical security compromise of data being leaked or the application going down or a denial of service. It's also a big impact on our economy. It's a big impact on our business operation. And this can also have an impact on our public image. So now securing our applications is just not only a security it's not only important from a security standpoint, it's now vital to our business operations. And we asked them, like, well, what are you guys doing to actually solve this issue? And 55% of them said that they are still actively looking for a solution that can be automized and integrated to their DevOps cycle. Why is that? We're seeing a growth on obviously agile methodologies and DevOps on the development culture of Latin America, but we need tools that are easily integrated to our workflow, and that we can extract as much benefit from them as possible. And that kind of automation and easy integration is not easily found. Thankfully, here you'll have some examples later on where Jason talks about Semgrep's possibilities, but this is a real a current need, and this is something that the market and the region is looking forward and looking after carefully. So let's talk a little bit about vulnerabilities and how this is how we're seeing them on the region. And we talked with the CISOs, and they mentioned that 91% of them have consciously deployed vulnerable applications. And then there's a really good question, like, why is this happening? If we know that our attacks are ramping up year after year, if we know they are targeting our applications, why are we still deploying consciously in a conscious way vulnerable applications to production? And here I have three case scenarios why this is happening. This is the three most common replies that we got. And the first one is one I think is actually even rather funny, is that they hope that the vulnerability wasn't exploitable. So it's not that we got to the point that we don't know, or we cannot actually test or understand if this vulnerability is exploitable or not. That can be through a series of issues that I'm going to talk about in just a minute, but just to understand, we're just hoping that the vulnerability is not exploitable. Why can this happen? First, maybe our team isn't capable of understanding this or having the knowledge to see if the vulnerability is exploitable or not. A second thing is that the tool that I'm using is not able to provide me that information. So neither can my team nor my tool that I'm using be able to justify me if the vulnerability is exploitable or not. And maybe I don't even have the talent in my team to remediate this vulnerability. So what's left for me? I'm just what I can do at the end of the day is just have my fingers crossed and hope that this is not an actual vulnerability. It might be a false positive and not exploitable. And what we're seeing with these responses, in this case scenario and the other two I'm going to give you, is for those companies that actually got breached through their applications. So we're seeing that one of the main reasons is just that I don't have the amount of coverage, or I don't have the talent to understand that vulnerability, or the tool isn't able to give me that information, and I'm just with my hands tied, and I have to hope for it to not be exploitable. When we analyze the two other key points of vulnerabilities that went to production and were later on exploited, we have these other two. So you've seen that the first one had an 18%. This second one also has an 18%. And it was to comply with a business, feature, or security deadline. What's important with this is that sometimes security teams have the knowledge that this is a vulnerability that we need to solve. Sometimes we understand the criticality of this, the risk of the vulnerability, but we don't have the time to solve it because we are pressured from a business or feature standpoint that we need to comply with this deadline and we cannot stop the process. Or sometimes it's from a security standpoint where we have an even more critical vulnerability on production that we need to solve, and we're switching risk. We're maybe remediating a critical risk vulnerability, but leaving or sending to production a medium risk vulnerability. This is kind of tough to tackle because we can, from a security point of view or from our security teams, we want to give what's best for the business and the most secure flow, but we normally don't have the time to do it, or either because we actually are quite pressed on the deadline, or because our time to remediation, our mean time to remediation is longer than expected, or is longer than what the market average is. So how can we tackle this issue? If we have a tool that's that can provide us guided remediation or help us with remediation insights, we can actually reduce the mean time to remediation, and then we can be sure that we're seeing vulnerabilities at the right time and that we have all the tools available to solve them before this deadline. And the last point, sorry, Jason, just one more.
Yeah,
and the
you're
last
good.
point is in this 40% is when the vulnerability wasn't exploitable. So our team did the test. We know it's not exploitable. Maybe our tool actually also told us that it's not exploitable, but the vulnerability was in the end exploited. This can be for two main points. One, and the biggest threat here, is the innovation of the attackers. Attackers obviously are all the time developing new techniques and new ways to vulnerate and exploit paths on our applications. So we need to have a process that is evolving, it's growing. We need to understand what the market trends are, be in touch with the community to get information about what's going on and new risks, but also have a tool that can easily adapt to what's new. So it's important that we have a tool that we can provide feedback on what we're seeing on, and that tool is also monitoring the market and the trends to adapt itself to new situations. So one of the main things, as I mentioned, is the innovation of the attackers. And the second thing, it comes from a design standpoint, that sometimes we see that the vulnerability isn't exploitable, but then how we are actually implemented might lead to an exploitable path that we haven't found. So to enter my final part of what I'm going to say is what I've been seeing that are the main pain points here in the region, and what are the new risks that we are facing, our security teams are facing in the region. First is AI coding. Developers are already using, but it's catching a trend here, and it's being every time more public and more incentivized to use AI to code. This impacts obviously on a positive way for companies, is that their times to develop and their time to market for applications is being greatly reduced. So we're able to code faster and to code more applications. That's great for the organization, but it's also a great risk and a great challenge for security teams. Why? Because a team of developers that used to develop in a certain time, they had their own mean time to market, and we were able to catch on to that time to develop, are now faster. But we, from my security team isn't growing. They're like developing, like if their team had grown 2 times or 3 times in size, but my team isn't growing. So now for smaller companies, their surface and perimeter, as I mentioned at the beginning, it's growing at an even faster rate that security teams aren't. And we need to have tools which we can rely on what they do, but not also that they do the security analysis correctly, is that they give us information in a correct, simple manner, so we can know what we have to action and what we kind of have to leave behind. So it's important now with the trend of AI coding that we pay attention to our security teams and their new challenge of this exponential growth of the surface that we have to secure. And the second point is something that we've seen for the past couple of years, and it's the lack of remediation. This can happen for a lot of reasons. 2 of the main reasons is when this whole process it's led by the security team, and the development team doesn't understand their role on this or their responsibility in having a secure and clean code. So that gives us a kind of like distance between the 2 teams, and we have to help everyone bridge this distance and give them the correct information, that this is an obligation for everyone in the company to have secure applications, but also to bridge the gap for them to understand what they have to do. So the other point in lack of remediation is that sometimes our developers don't know clearly how to remediate. So we have to give them clear remediation guidelines, try to help them with auto remediation, and try to help them understand what's the risk of each vulnerability. Once we start a process of a secure SDLC, our developers are going to be learning on the meanwhile while they remediate. And in the long run, if we have a tool that's able to give us all this information, as Semgrep can do, our developers are actually going to learn how to avoid these vulnerabilities once they code. Other of the pain points we have, it's on, and this is more for team leads, C-levels, or team managers, and it's the absence of metrics on what I'm doing. We normally have to be able to say and share what we are doing, but also understand what's going on my company, understand how this process is benefiting it, but also be able to see trends on, for example, vulnerability growth, that I'm seeing more vulnerabilities on my code than previously, or my teams are taking longer to do the remediations. Having clear metrics allows me to understand what are the trends and what's actually going on my company, and it empowers me to take better decisions and to further develop this process on my company. But also metrics aren't the only thing that we need. We also need key performance indicators and dashboards. What we've seen is that obviously key performance indicators are a must for every team lead and for every manager or C-level, but dashboards are actually useful for everyone. If we have a clear dashboard for the developers on their project results, they will be able to understand what's going on at a simple glance, and they will be able to do their work on a more efficient way. But also for team leads to understand what's going on with their team and try to tackle what's most critical, but also tackle some potential points where they can improve and do a better job. And the last point, this is actually uh, just a result of everything we have, but we've seen a lack of know-how on how to do vulnerability prioritization properly. How do I prioritize which vulnerability should I solve first? As we've seen with clients that are implementing these tools for the first time, or they're actually managing a big backlog of vulnerabilities, or just on their day-to-day basis, there's an issue when you just detect 100 vulnerabilities and 40 of them are critical. Which one is more critical than the other? So it's important that we have the know-how how to do this, which isn't something that we can easily grasp from one day to another. So having a tool like Semgrep, where we can actually see which vulnerabilities are important and which vulnerabilities are key to remediate, actually helps us do this prioritization properly, and we will be able to solve what actually poses a real risk and a real threat. Just having a risk level for the vulnerability is not enough. Sometimes critical risk vulnerability, we might think that it's the first one we have to solve and remediate, but there might be a medium vulnerability, a medium risk vulnerability that is actually exploitable. It has an exploitable path, and it's easily exploitable, and there's a way to do it, and we know that this has been exploited on the market, and that might pose a bigger security threat than the critical one. So having a tool like Semgrep, which does this process for us, it helps us to actually get this know-how, but also so it actually allows all of our developers to benefit from this know-how potential of vulnerability prioritization. And what's the biggest pain point that we're seeing on the region is that when we don't do all of the things that I talked previously, when we don't have a security team that's conscious about these risks, when my organization isn't conscious of what should I be doing to actually improve the security, and what should I be actually implementing on a tool standpoint, we all have a false sense of security. So sometimes using tools that aren't doing their job properly, or that aren't configured properly, or that aren't implemented or adapted to my flow properly, will give me a false sense of security. So in that case, or in that pain point, both Semgrep and us from Lugapel can help our clients or potential clients to get the correct tool, have it integrated to their workflow properly, check the rules that they are using, try to and help them adapt their tool to their process, train all of the developers and the security teams, and also the C-level to understand that we are with all of uh, our joint efforts. Now we have a true sense of security that's backed by our work together. So, with that said, I hope that everything's clear from context-wise for the region, and I'll leave now the floor to Jason so he can show you what's the benefits and what Semgrep can do to help us solve all these issues.
Yeah, thank you so much, Matthias. It really helps kind of lay the groundwork and the foundation for kind of where SimGrep fits in the market and the overall trends that we've been seeing on the application security side. Um, Now, I want to talk about the work that we're doing as SimGrep, but I want to also contextualize it kind of in the overall application security testing ecosystem. Um, there's a big push right now to be, more developer centric, but it's important to note that it always hasn't been that way. Um, when static analysis tools, so tools that analyze your application before it runs, kind of first came out about 25 years ago. They really were tools built by security people for security people in a world where security was just kind of a gate at the end of the security development life cycle, or sorry, the software development life cycle. These were compliance-focused tools that were slow, really hard to deploy, and ultimately had some really good stuff, but often it was buried in a lot of noise that the security team would kind of have to go through before sending it to the developers. As Matthias talked about, we've had this rise in DevOps culture, and organizations are adopting DevOps practices and releasing code faster, hundreds of times faster than ever before. They're releasing continuously, maybe weekly, maybe daily, and the kind of security testing that these original static analysis tools were built to support doesn't really fit into a DevOps workflow. In fact, most of them were kind of left out as pipelines got built because security can't be a blocker. Development is going fast, and anything that slows it down is seen as friction that needs to be removed. CI/CD is focused on continuous improvement. It's not focused on compliance. And so we really needed to see, these kind of old tools shift their tactics and how they actually engaged, not only with the software development lifecycle, but with developers themselves. And so these SAST 1.0 tools, they started to kind of pivot. You saw, a whole bunch of marketing around the topic of shifting left of, hey, right now we're testing pretty late in the software development lifecycle. Let's move it earlier where, a developer can actually see results closer to when they, coded some kind of vulnerability. And hopefully they can fix it there where it's faster, it's cheaper, it's more secure, and so on and so forth. This is a really great idea in theory, but unfortunately, the way that a lot of these older tools implemented shifting left left a little bit to be desired. Oftentimes, it was just taking the same SAST 1.0 tool, which was slow and noisy, and just kind of turning it towards the devs and saying, all right, devs, well, it's off security now. It's your job to deal with all these findings. And that is not very practical. Devs are all of a sudden saying, hey, we have all these findings in our workflows. A lot of this stuff is not real. It's wasting our time. And so, what I see a lot of orgs who come to us where developers are so frustrated that they turn off the tools themselves or they just ignore the findings altogether. And ultimately, security just doesn't happen. So what we really focus on here at Semgrep as what we call ourselves a SaaS 2.0 company, is really delivering on those promises of shifting left, of helping shift the burden off of the small security team, which is, wanting in both resources and personnel, um, and helping spread that onto the developers who ultimately are the ones writing the bugs. And so the two things that we want to be able to promise to our developers are, one, we are only going to ask you to fix things that are real. We're not going to send you noise. We're not going to waste your time. Um, that's ultimately our number one priority. And if we do send something to you, number two, that has to be really easy for you to fix. We know you're not security experts. Developers have so much that they need to learn and know. Um, we're not going to be able to convert them all into, miniature security gurus, but we can give them, easy ways forward to fix issues as soon as they come up. And that way, developers can fix things and get on with their life and do the thing that they really want to do, which is ship new features. And so those for us are really kind of our guiding principles in how we approach static analysis. Now, what makes Semgrep, what makes static analysis so prone to false positives? And I have a little example here. So here's some code that a developer decided to push. They open up a pull request, and Semgrep takes a look at it and says, hey, I notice you've got some potentially attacker-controlled data coming off of an HTTP request, and it's ending up in another post request. And so in the developer's workflow, Semgrep sends them a comment and says, hey, this might lead to server-side request forgery. That could be a problem, and blah, 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 blah. And that's awesome. We get to notify the developer gets to see this and deal with it early. But there's one problem, which is that the developer actually already dealt with the issue. They used this internal utility library, this method called validate proxy request, which was used to validate that data. But unfortunately, Semgrep, out of the box, doesn't know that that's what that utility library does or that's what it's for. And no other static analysis tool, whether it's Semgrep or others, is going to know this kind of thing. This is business context. This is code context that unfortunately the tool is missing out of the box. As a human, I can look at this code and I can see and say, hey, I see the developer tried to validate. But the static analysis tool is kind of dumb. It only knows what it knows. And so we really have been focusing on taking kind of the predictable and formal nature of static analysis, which can find some really cool stuff, and then marrying it with more of a human understanding, something that is context aware, that can look at the code and provide a fresher set of eyes than what kind of the automated testing of SAST can do. And so we decided to marry both static analysis with generative AI to deliver kind of a hybrid approach that our customers have found extremely useful. And this is what we call Semgrep Assistant, which is our AI AppSec engineer. Assistant is there to help your small security team scale both triage and remediation, and ultimately help reduce your backlog and get your developers to fixes as quickly as possible. Now, so how does Assistant do this? What does it really do? We still use the SAST engine to identify potential issues. And so we'll take all of our findings and we'll then say, hey, Assistant, take a look at these findings. What do you see? And Assistant is going to try to triage those findings. It's going to use, kind of the knowledge that it has. It's going to use the past triage that you've done on similar issues, as well as organizational context that you have fed to it. You've said, hey, we do things this way at our organization. So we can really start to cut down on the findings, and then we can start to contextualize them. So a lot of the times we have these hundreds of findings in backlog, and it's unclear what do we really need to prioritize. Well, with Assistant, we can actually contextualize. Assistant will look at the code and the module it's in and say, is this a risky component? Is this related to maybe authentication or authorization? Or is it a test script that no one really cares about? And so we can start to kind of prioritize things. And then finally, and the biggest one, is generating remediation directly for the developers. So what would a fix look like for this vulnerability here in the code and also in the context of your organization's security best practices? And so that way we can kind of take what, old tools would just have these raw findings. We can really take those and whittle them down and get to fixing the things that matter. Now, what does this look like in practice? Well, I'm going to swap over to the kind of Semgrep platform. This is really for us a place for the security team to kind of control the scanning program. Ideally, in a good Semgrep program, developers never have to come back here. Developers get to stay in their workflow, and they get to work there. We'll interrupt them when we only feel something is important. And so, of course, we're going to do the normal kind of program tracking of like, what is your open backlog over time? Are you fixing those findings? Is that backlog going down? But I think more importantly, we're really tracking what is the engagement with your developers? What percentage of findings is being shown to them? Are you actually shifting left in your application security testing? So I can see what percentage of findings are we actually surfacing to the devs? And not only that, but what are they then doing with those findings? If I show something to a developer, are they actually fixing it? Are they ignoring it? Are they just, kind of just not even engaging with it? And so we're tracking all of that. But more importantly, you'll see there's this silenced bucket. These are issues where we originally were going to show it to a dev, but then Assistant took a look at it and said, hey, I think this might be a false positive. Let's just not even show it at all. So that way we're making sure through this kind of noise cancellation that everything that reaches a dev's lap is real through that triage. So if I click into one of these issues that was suppressed, I can now see it. Here I am looking at the particular issue. I can see, here's the file it was in and a brief summary of it, as well as here's my code and kind of the data flow for the issue. And you'll notice Assistant made a judgment here. So it took a look at the code and it said, hey, I notice it's passing through a sanitizer. And so this payload is neutralized and this is a false positive. So ultimately, through the help of Assistant, we can prevent this noise from ever reaching the developers and not slow them down, not waste their time. So that's us delivering on that first promise of only sending you real stuff, developers. The second promise around giving you an easy fix, I'll show what the developer workflow actually looks like. So the developer is going to be working probably in their source code manager. Maybe that's GitHub, GitLab, Azure DevOps, Bitbucket, whatever have you. And Semgrep runs super fast. So when a developer opens a pull request, Semgrep runs. It's going to take maybe a minute, maybe 2 minutes, but get the results back to the developer on the changes that they made. And it'll post it as comments, as a code review. So Semgrep is going to say, hey, here's a potential SQL injection issue, for example. And we're going to give the developer everything that they need to deal with this issue right here in GitHub or their SCM so that they can work with it. So if there's some kind of data flow proving the exploitability of the issue, so in this case, user data coming from this HTTP request and flowing through to this SQL statement, without being validated or sanitized. We're going to provide that. And then Semgrep Assistant is going to come in and say, hey, here is a fix that is relevant to the code. So the developer can see directly, if I were to fix this, this is what it's like. They could commit this suggestion automatically. And they also have step-by-step instructions if maybe they're unsure what this all means. Or maybe they just haven't dealt with a SQL injection issue before. And so all of this is kind of at their fingertips. They can work with it. They can auto-commit the suggestion. But ultimately, we're trying to give them as much information as possible through the help of AI so they can get to the fix and keep moving with their day. This is kind of the two ways in which we're enhancing static analysis with Semgrep Assistant, both on the triage front and also here on the remediation front. Now, I've talked a lot about how it's kind of improving developers' lives, but I also want to talk about how it can kind of improve security's lives as well. Um, security often has a backlog of findings, and they want to work through them. And with SimGrep, with static analysis in general, oftentimes if you see one false positive, you're going to see tons of other versions of that same kind of false positive pop up again and again and again. And as security, it's kind of exhausting to keep playing kind of whack-a-mole and hitting these different similar issues as they pop up. But with kind of our AI assistant, it can start to learn from the triage you do and from the history of your scanning. So um, we call these kinds of learnings memories. So the AI can learn and basically acquire memories of how your organization works and how your triage functions over time. A really great example of this, one of our Fortune 100 customers, financial customer, they had like thousands of potential server-side request forgery findings. Um, and, Assistant took a look at them originally and just said, I think 9% of these are false positives and the rest are all real. But when the team actually looked into these findings, they noticed some trends. Um, and we decided to take those kind of trends, the reasons why these were false positives, and turn them into memories for Semgrep Assistant. So they made two memories. The first is they noticed that sometimes the URLs being built were being built from static data that was being managed by their Spring configuration framework. And so they said, hey, assistant, when you see, these kinds of values being managed by Spring being used, it's not a problem. It's a false positive. And then also they noticed sometimes the data was coming from their own internal services. And Semgrep and any other tool out of the box, we don't know what your trusted services are. We're just going to kind of assume that it might be an attacker. So they were able to create a memory for that saying, these are our services, and if you see data coming from them, it's a false positive. And so just with those two memories, they were able to rerun Assistant on all their findings and reduce it by another 38%. So they were able to take their backlog and just shred 38% of the backlog just with these two memories. And you can kind of see some of Assistant's responses with this new context in place. So this is a really great way to take the work of one, security engineer and scale it across hundreds of findings. Um, and so in the product, the actual assistant's memory page, these are what the memories kind of look like. So you say what project you want them to apply to and what rules. Um, and the cool thing is these memories, they can apply to the triage, like I just showed you. They can also apply to remediation advice. So if your organization has specific standards by which you want developers to remediate things, you can tell Assistant that, and Assistant will incorporate it in the remediation advice it gives to the developers. So a great example is this memory here, where security team has their own internal logging service, and they've got, they want the developer to use that because it's a secure version of their logger. And so they created this memory, and then Semgrep, when it found a log injection vulnerability issue, then recommends that logger. So just like the security team wanted it to, it tells the developer, here's how you import the logger, here's how you initialize it, and then here's how you would actually use it in your code. So this gives the security team the power to scale their knowledge to all of the developers and basically take what are best practices and really make them uniform across all the recommendations by their security tool. And so that's the power of AI memories, both for triage and for remediation. And I would say this is kind of the bread and butter of what we're doing here. Really taking the fundamentals of static analysis and enabling your developers and also scaling your security team with the help of AI. Now, what else are we doing with AI? I think, one of the things that Matthias talked about was there's a lot of AI generated code. And Semgrep is actually helping you secure that. We recently released a new MCP server. This is a plugin that plugs into AI IDEs like Cursor or Windsurf so that as developers generate code with AI, Semgrep just automatically runs and scans it and makes sure it's bug free. Um, so this is cool. You can check it out at github.com/semgrep/MCP. Um, and you can make sure that, yeah, that AI code is secure. And then last of all, kind of what's the future for us? Right now, we've been so focused on triage and remediation, but I think, it's kind of these buckets here and prioritization. But I think for us, we're really focusing on expanding assistance reach to also talk about security policy. So figuring out, what repositories are maybe the most vulnerable and helping prioritize that way. And then also writing custom detections. So if you have a bug bounty or pen test report, having Assistant take that and then write that into a rule so that you don't have those issues reoccurring throughout the code base. So that's really the future for us. Just kind of taking AppSec, putting it on an autopilot, and hopefully saving you and your developers tons of time and energy. So with that, it's kind of what I had to present, at least in terms of the exciting things we're doing here at Semgrep, um, enhancing static analysis with AI. But I'd like to open the floor to the audience. If you have any questions based off of what you've seen today, I'd love to hear them. So if you have anything, please go ahead and drop them in the chat. And either Matthias or I will be happy to respond.
Jason, Sarah is saying that there's a question about how we surface false positives.
Hmm. Yeah. So the false positives that we see, let me go ahead and take a look at our findings. So, we don't show them to the developers, but all those false positives we still want the security team to have visibility into them. We don't want to ever just ignore something without security at least being aware of it. So right now, here I am, like looking at all of the findings across all of my projects, and I can take a look and filter by the ones that Assistant thought were false positive. So if I do this filter, you can see for each of these findings, I can see here was Assistant's judgment, and its reasoning why it thinks that something is a false positive. So I can, kind of agree and ignore it or disagree. And if I disagree, I can provide a reason why Assistant's judgment is wrong, and the Assistant will learn from that. So I can add a memory that kind of teaches Assistant. Maybe Assistant was too, kind of um, overzealous in its judgment. Um, so overall, it'll keep learning from your feedback. But yeah, these are where the false positives are going to kind of live.
We have another question on the chat. It says, for LLMs, what are the boundaries of where the source code is sent to? Are the
Sure.
LLMs within Semgrep infrastructure?
Yeah. So by default, we have a zero data enterprise agreement with OpenAI. So here, let me go to the AI provider settings. So if you're using Semgrep kind of out of the box, we will send your data with OpenAI. That's the main source of our models. We're constantly testing them to see which ones perform the best. And so we might change out the individual models, but they're all OpenAI owned. If you don't want to use our models, though, you can actually bring your own. So if you have something on Bedrock or you're using Gemini or XAI, or even your own OpenAI like API key, you can bring that in and use your own models. So we're very flexible in where the kind of LLMs run and hopefully can suit whatever kind of security, posture that you need.
I'm not seeing any more questions, but I just wanted to wrap up with a comment. I believe that what Jason has showcased for us actually solves most of the issues we talked about previously. having an assistant that I can give it input of what I'm seeing on my company or what my company does, and it can actually adapt to my security needs. Actually, what it does is just potentiate and augment or grow the reach I have as a security team. So as much as the developers are using AI to improve their performances and the development and the growth we've seen in applications, we can also leverage that same technology to help us from the security standpoint to actually be able to fulfill our objectives and mission on the company and have uh, an extended reach inside a company. So that's my final comment, Jason, from my side.
No, thank you. I think it's important to consider. Yeah, well, I want to thank you all for attending our webinar today. I hope you kind of learned more about the current state of static analysis and the industry, and hopefully we're inspired by the things that we do here at Semgrep. Again, we're a application security solution that covers both static analysis, software composition analysis, and secrets. So if you're looking to, upgrade your program or maybe kick off your first AppSec program, we're happy to consult and talk. But yeah, thank you for your time, and I hope you all have a wonderful day.
Thanks, everyone. Have a great day.